And I think maybe, let's see, I believe that we are live. We're there.
Well, welcome. I'm Dave Eicher, and I'm here with Allison Klesman and Jeff Hester, and we welcome you once again to Scientists Stuck Inside. We hope you're enjoying yourself, your isolation, and glad you're here to talk science with us. Today, we're going to talk a little more about COVID and everything that's going on to transform our world and what's really happening, the realities of what we know with the science. But first, we're going to talk
Is
about.
that legal anymore, Dave?
Oh, yeah, at least
okay.
in this household here.
Okay.
Yeah. Yeah, but I'm in Wisconsin, so who the hell knows what's legal here? You know, it's kind of a frontier prairie here. But I tell you, first, we're going to talk a little bit about broader things, about it's a big universe out there. We have one little planet that's in turmoil here, but there are a whole lot of other spots out there in the universe. Now, not to get too sidelined, but, you know, there's this concept of cosmic inflation that we believe in cosmologically. And if cosmic inflation is true, among other things, it explains a lot for us that we observe in the present day universe, but it means that the universe that we can see is not nearly the entire universe. So let's just talk about the visible universe, which may not be anywhere near the whole big deal, but there are at least something on the order of 10,000 billion stars in the universe. We also know that chemistry, I'm the son of an organic chemist, and so I was around chemicals a lot. Actually, everything's made of chemicals. That's a chemist joke.
Except for 95% of the universe, but we'll set that aside.
and except for thoughts, and except for thoughts too, which are only the byproducts of chemicals.
Right.
But we know through spectroscopy, that magical tool from the mid 19th century, that chemistry in the universe is uniform, that chemistry in physics, we believe, works the same way everywhere in the universe. So here's the conundrum. We know of one place in the universe out of those almost infinite number of worlds where life exists, right here. And we're having a little bit of a hard time with life right here now too. But my question to you, Allison Klesman, to begin with, is, with all these star systems out there, 100 billion galaxies in the present day universe, 10,000 billion stars, we see planets around most all the stars near us in the galaxy. What do you think about the odds of life being out there in the universe?
I think it's pretty good. I honestly think it's a little ridiculous to think that there is nothing else out there. Given the numbers and given the ways that we know things can combine. I mean, again, it might not look exactly like us. It might not, might not be something that we recognize. I mean, and there's a lot of work, we've had a lot of articles in the magazine on what would life look like, even say on Titan, which is in the same solar system. And while it would look similar, it's not going to be based in quite the same chemicals, but it's still made of the same things. It would still probably function much the same way, even if you're substituting certain elements or molecules for others. And I think it's pretty unreasonable to think that there is not life of some kind out there somewhere. There's a lot of planets. I mean, it's an average of one planet per star, at least in our galaxy, we're pretty sure now. So it's a lot of planets.
Yeah, at least.
And
So,
maybe a good deal more than that,
right.
But that would be hundreds of billions of planets. And some people have estimated that Earth-sized planets, even, there could be something like 1 trillion in the Milky Way.
Yeah.
Even.
Yeah.
But that's a supposition. That's an extrapolation. But let me just quickly, before you take over, one thing just to build on what you said. No, it's okay. But just to build on what you said, Allison, there's no magic here. There's no need for magic. You don't need to magic things into existence. This is something that Richard Dawkins likes to say a lot. Chemicals, and I like to think of minerals and mineral collecting in one sense, because that's so much fun. It's planetary geology. We can see the way the universe assembles substances in minerals. The various atoms that come together to form substances are attracted by electrochemical charges. So they combine not in random magical ways to make things, in ordered ways, in crystal lattices that the universe has devised. So you could have, in fact, even though temperatures and pressures and all sorts of other conditions are different on other planets, you could have, for example, minerals, or maybe even really complex molecules, maybe even self-replicating molecules, maybe even very complex compounds that really assemble in very similar ways to the way they do right here on Earth. Jeff, what do you think about all this?
Well, of course, it's the answer to that. It's kind of fun because until sort of the middle of the last century, people had no clue that there were natural processes that could lead to anything like life. And the first break in that, and oh God, did I just forget the name of the mind is the first thing to go. You're going to say it, the experiment with the bottle and the spark and
Harold Urey and Stanley Miller.
Yeah. The Miller-Urey experiment. Yes,
fact,
yes.
My father for the Manhattan Project worked for Harold Urey.
Really?
At Columbia, in 1942, but that was to invent bombs.
Yeah.
But anyway.
Yeah, that's a fun stories there. I always loved the story about Richard Feynman, who was quite the character.
Yes,
at one point, I guess he found a hole under the fence into Los Alamos.
Yes.
And so he did a thing where he'd slide out through the hole and then he'd come around to the gate and come in, and slide out through the hole and come around to the gate and come in, and slide out. And he just kept doing this until finally the guard says, "What the are you doing?" And he said, "I'm just demonstrating non-conservation of Feynman."
Nice. And
anyway, the Miller-Urey experiment. They did this thing where they took what seemed like some reasonable approximation of a mix of the stuff that was around when the Earth was young, hydrogen and methane and stuff like that with water. And then they put a spark in it and they just let it go. The idea being that the spark was maybe something like lightning or UV from the sun or some such. And much to their surprise, when they came back after a while, this thing that had just been, clear liquid and gas in a jar looked like this brown goo. And they dug into it and found all of these complex organic chemicals, the kinds of things of which life is built. And in fact, since then, people have gone back, that goo, I guess, is samples of it are still around. And people have gone back and looked, and there are amino acids, there's all sorts of stuff. And so that's the first thing. If you imagine that somehow you have to have magic to make the chemistry, you don't need to have magic to make the chemistry. We knew that. I mean, we know that in lots of ways. The fact that when you look at interstellar clouds, you find them containing all sorts of complex organics. It's just, okay, so that's easy. The next question becomes, okay, how do you go from that to anything vaguely like life? And there's been some recent really fascinating work by a guy by the name of Jeremy England out of MIT that's thermodynamics of all things. And to make a very long story short, everybody has heard about the second law of thermodynamics, the onward march of entropy, which people don't understand, and that would make a good conversation sometime.
That's the thing that's going to kill us all eventually.
Except
I've heard of that.
The irony though is people think, oh, entropy stands in the way of this process. It's actually entropy that drives this process. It's the fact that what entropy says is that the universe, by random processes, is always moving in the direction of more and more likely configurations. And Boltzmann was having trouble explaining that. He's the one that came up with the notion of explaining it by atomic motions and such. And he, to make people understand, he started talking about this thing called disorder, and it stuck.
Mhm.
But disorder is kind of a crummy way to look at it. I mean, you know, we are here, I am here in a place where it's hot enough outside that it would make sense to take a glass of ice water outside and drink it. That one's for your benefit, Allison. So how is the weather there?
I just took a walk around for an hour before this. At 40, it's cloudy and 48 degrees, you know,
Feels
and a
pretty
little
warm,
breezy.
though.
Yeah. I want to be in Arizona is what I want to be.
Yeah.
Aha, I gotcha.
Yeah,
Well, it's fine now. Give it another very little bit, and you know, I'll trade you. Anyway, but that if you got a glass of ice water and you take it outside on a nice, humid summer afternoon in Phoenix, and you sit there, what's going to happen on the surface of the glass of ice water?
There's no humidity in Phoenix. What are you talking about?
Oh man. Oh, and of course, everybody who's spent any time in Phoenix or anywhere in Arizona at this point gets the joke. But
I miss that so much. I lived in Florida before that, though. So if you were to do this experiment in Florida, it would be very different.
Well, you do it in Phoenix. Okay, we'll do it in Florida. We'll do it in Florida. What happens?
You get water on the outside of your glass.
condensation.
Yeah, and what does the water look like?
Drops.
Bunch of little droplets.
Yeah.
Little beads. Mhm.
Yeah. And so you look at it, and clearly that must be a violation of the advance of entropy, right? Because before, that water vapor was just sort of this random water vapor everywhere, and it was incredibly disordered. And
It's
now all of a
organized.
sudden,
Mhm.
now all of a sudden it's sitting there in these nice little ordered droplets. So what's up? What has happened? Is that some magical violation of entropy? And the answer is no, it's not. That what has happened is that in that process, you warmed up the water in the glass a little bit, and you melted some of the ice, and so on and so forth. And those are things that are increases in entropy. And so it turns out that the most efficient way to increase the entropy as a system as a whole is to form these nice little structures on the surface of the glass. And that's an idea, that's kind of a hint of an idea that this guy Jeremy England took and played with, and showed that if you look at the most effective way that entropy can increase, which is what entropy tends to do in places where energy is flowing, that it tends to make structures that are really good at taking ordered energy and turning it into thermal energy, that like to do things like replicate themselves, that so on and so forth. So yeah, entropy isn't a problem. Then comes the chemistry side of things. Well, gee, how do you get self-replicating molecules? It actually turns out at this point that in the lab, they have put materials, you know, metaphorically, sort of metaphorically, they have put materials in a test tube and seen those materials go on to form molecules that not only replicate themselves, but that actually speciate. That you wind up getting different varieties of these molecules, and the different varieties of these molecules then wind up, you know, competing, not in an intentional way, but just the chemistry. They wind up competing for available resources. And so we have seen the appearance of self-replicating molecules in the lab. Once you have that, now you kick in and you say, okay, how much opportunity do you have? The number of atoms in my thumb is roughly the same as you were talking about stars, the number of stars in the entire observable universe. Okay, now imagine how many atoms there were, how many molecules there were in the entirety of the young Earth's oceans. Now imagine that you've got something like, oh, a few 100 million years to play with.
Yep.
It's just not, you don't have to stretch very far to imagine that you produced a single self-replicating molecule by chance.
That's right. And then eventually you also have to have a cellular structure, something to contain this stuff in, but that's relatively straightforward too.
Yeah.
So that the proteins and the RNA and DNA can be having a party all in there together. But that's actually more straightforward than the self-replication.
Well, maybe,
Probably.
maybe not. The point is, though, is that, okay, you've got a single molecule and it replicates itself. So now you've got two of them.
Yep.
So what do those do?
It's just like the shampoo commercial.
Yeah.
Once
you
again.
Tell two friends.
Yeah.
You tell two friends.
It's a good segue, actually. It's been 15 minutes.
Anyway, by the time you get through maybe 100 generations of this,
yeah,
then you start counting. Well, imagine that one out of every 10 billion times there's a mistake in the way that this replicates, which is an insane, it's actually much more common than that. And let's imagine that one out of every 10 billion times, one of those replications makes the molecule better at replicating itself.
And therefore it goes on more successfully, and you have natural selection beginning.
You've got natural selection. And so after just 100 generations, you not only have something like 10 to the 30, a 1 with 30 zeros behind it of these molecules in principle, but you also have had something of order maybe 10 billion mutations that actually make them better at replicating. Okay. So there's that aspect of it. Then as you say, all right, how do you go from there to more complex cells? It's just the same process going on.
For a long time is all that's required. And we've had a long time in which to do that.
Yeah. And so it's, given what we know, I think that the only reasonable expectation is that there should be life throughout the universe. And then you come to the
thing that we're not in the center of everything and that we're not more important than every other place in the universe.
We figured that one out a while ago.
Figured that.
Okay.
Although interesting, I mean, this actually goes off into another conversation we ought to have sometime, which is the whole business of parallel universes and the multiverse and so on and so forth.
That would be a fun conversation.
Because there are people that say, oh, no, that can't be. And I hear that and say, that's all that insistence that it can't be is sort of the earth has to be at the center of everything notion.
Well, and you can't even necessarily, now the arguments are whether you can actually perhaps infer evidence in our universe of other universe, that it's not for all time until the heat death of our universe unanswerable, that maybe you can detect evidence.
Yeah. So that would make that, that'll make a fun conversation. Who knows? Maybe next time we should talk about.
But meanwhile, we've got this terrible, peculiar situation down here on our planet.
Oh no! You didn't let me make it to the segue.
Oh, I'm sorry. Okay.
I was about to do the segue, and the segue I was going to do was to say that there are actually things. Another thing is that there's not even a clear line between things that are living and things that are not living, but that's a blurry line.
Well,
and there are these things called viruses that are sitting there on the razor's edge between the non-living and the living. So now
that are technically not living. However, so Allison, you have some breaking news, I understand, about this COVID-19 situation with some insider technical details from the great windy city of Chicago. Is that the case?
I do. So at least some places in Chicago are offering the antibody test. I believe it's the same test as the Germans. I think it's that same test that the Germans developed. They said it would take, I think, about 2 to 5 days to get results back. So it sounds like it's, gonna send it to a lab and get it back. But I believe they're gonna. I mean, my sister called and was able to get an appointment on Saturday, and I think she called yesterday. So they are at least, they do at least appear to be pretty available, which is, a step in the right direction. It's not quite not quite the test we also want to make is available, because we want, general COVID-19 testing to be that available, but it's clearly a step in the right direction.
Oh, fantastic.
Yeah.
So does she imagine that she has had it?
She hasn't been sick.
Okay.
So if she's had it, she would not have had symptoms.
Okay.
So it's a little bit more out of, I think it's somewhat curiosity, somewhat, wanting to know if you can go back out into the world. I mean, again, if someone offered me that test today, I would take it too. I don't think I've had it. I haven't been sick.
Yeah.
I've only been out of the house once since since this all took place, although I was in Louisiana, right when things started shutting down. But
You didn't go to Mardi Gras, did you?
I did not. I went a week after Mardi Gras.
Okay.
So we timed it to not go during Mardi Gras. But
So
I don't know how,
You went just at the time that the community contagion, the community transmission for Mardi Gras was really getting
exactly. And I went with my sister,
established.
which again would be interesting. If she tests positive, I'd be interested to know again. Is that something I could take? But it does seem like this is, again, becoming at least available. I can let you know when she updates me. But I think I think it was very interesting that she was able to get it so quickly, and she at least. It looks like at least her insurance is covering it 100%, which is nice as well. I cannot speak to all insurers or anything like that, but she was pleasantly surprised to see that.
Of course, why in the world would you make people pay for that with their insurance at this point? Because the information that we desperately need, I mean, we want to know what the prevalence of it is in a random sample of the population.
Oh yeah, I agree.
And so we shouldn't be waiting for people to call in and say, would you test me? We should be going into areas and testing everybody.
Well, we're all going to have to be tested eventually, and the sooner the better. So why not get it going now systematically,
Yep. I absolutely agree. But anyway, so go ahead, test.
Yeah, exactly. Again, I don't know how
fun.
Even widespread it is in, say, Wisconsin. I don't know if it would be able, be possible to go get this test today or anything, but
Yeah, well, nobody knows how widespread
hopefully we'll
it is
know
anywhere.
more soon.
One can hope.
I think there are at least a couple large cities, I mean, obviously Chicago included, that are starting to roll out the larger, widespread antibody testing. Again, there's still that question that I'm curious about, that I think everyone's curious about, is if you've had it but had no symptoms, does that really confer full immunity, or does it not? I mean, we don't know that yet. So I think this is a step in that direction as well.
So I mean, we have touched on that and kind of found that maybe our reading had taken us in different directions. The reading that I have done is sensibly optimistic about that.
Well, I think
they look at it and say that it that it has a reasonably slow mutation rate. That
I think
the kinds of
question seems to be not whether you're immune once you've had it, but it's more the severity of whether if you've had it but had no symptoms, does that confer immunity? Do you have enough antibodies? I think that's more the question.
Yeah.
Again, I don't know, is that true of other diseases? I genuinely don't know if there are other diseases that you can have it without really having symptoms and then be immune. I'm not entirely sure, actually.
I don't know. I mean,
I know
there are
carriers. So for example, in cats, there's a disease called FIP that I kind of
our daughter, actually, the youngest of our grown daughters has a cat. In fact, very young cat that got FIP, which is supposed to be a death sentence.
It's so and I believe it's a coronavirus.
And it is a coronavirus.
And cats can carry it and shed it, but never get sick from it.
Yeah.
And so and again, I'm wondering if this is something similar, and I don't know if they're necessarily immune to it if they get it and shed it and don't have, don't have symptoms. So it's interesting.
Yeah. Well, her cat is actually part of an experimental treatment.
Oh, really?
and is something like 7 weeks into this experimental treatment, is now up and bouncing around and putting on weight and all of that stuff. So
That's really good to hear.
there may be a future for
I hope so.
FIP
It's a serious
cats anyway.
disease. So I
Yeah,
mean, there are two different versions. There's a wet and a dry version, and one is kind of a death sentence, and the other is not. So
Yeah.
I will check back in with you on that. I'm curious.
Yeah, I will. That's maybe we'll have a. Did you have a cat that had FIP or?
I don't believe we have. So my mom bred cats for several years.
Okay.
And as a breeder, you learn about these kinds of things. You have to be very careful about cats that you bring into your home. You don't want to bring in a cat with FIP. If you were to have a cat that had FIP that was the kind that they can live with you, generally you don't get another cat. That's the cat that you have, or you have other cats that are FIP positive. So I know a lot about it just because of
Yeah.
breeding.
Yeah.
I don't think we.
Well, they had a cat that when they brought this kitten in, and the other cat seems to be okay. But
yeah, I mean, again, it depends on their immune system, and it's a I don't want to say similar virus, but it is a coronavirus. So
it is a coronavirus.
Somewhat similar.
Yeah. But yeah, so there are a bunch of questions that we really don't know the answers to. We're certainly hoping that asymptomatic cases convey some level of immunity, but
that would be ideal.
We don't know
honestly.
that.
Yeah.
We don't know that. We don't even know, again, the extent to which a difficult case of it conveys immunity, other than to say that most people, experts in the field tend to say it will certainly convey pretty good immunity for at least 6 or 8 months, and there's a good likelihood it'll be a lot longer than that. So, but and the same concerns apply to to vaccines and such as that.
Right.
So, but yeah, so what do you think about this whole business of, gee, we need to open things up? The dear governor of Georgia, there's a fun meme that's circulating on Facebook that says that, what is it, that Spain shut down the running of the Bulls, and Germany shut down Oktoberfest, and Georgia opened the massage parlors.
Yes. Well, but that's only for essential tattoos. Can you go to the tattoo parlors too?
Ah, okay.
Yes.
All right.
And the mayor of Las Vegas wants to open the casinos now again too,
Right.
Can you imagine that?
Well, given that the people who stand there in front of slot machines clearly already believe in magical thinking, I can understand that. But it's crazy. It is completely crazy. And the thing that's especially frustrating, first of all, if you look at what's going on, numbers are still rising. And in fact, if you look at there's one set of models that Trump especially likes to carry on about how great they are. The reason he likes to carry on about how great they are is that they're the ones that are the most optimistic of all of the models out there. So of course, those are the ones that he likes. But if you look at those models assume that once lockdowns are put into place, they remain that way indefinitely. And they assume that lockdowns here are as effective as lockdowns were in Wuhan, where they shut down all the transportation. They wouldn't let you into the city. They wouldn't let you out. All of the businesses were shut down. You were not really allowed to come out of your house at all. And now that they've opened up and they're starting to see new cases again, they're opened up as more restrictive than most of the shutdown that we have in the United States. Anyway, where was I going with that? If you look at it right now, the death rate in the United States is as high as it has been. It is not declining in the way that the optimistic models say it should decline. And in particular, what's going on is that, numbers are coming down in New York, which dominated the statistics for a while. The reason the numbers as a whole aren't declining is because they're really starting to come up in the rest of the country. And so what's going to happen, I am afraid, and I think the data suggest it and a lot of the models suggest it, is that what we're seeing right now, courtesy of lifting the restrictions, is that, you know, we're things have been going up, and if we had really clamped things down, things might have done this. But instead, things are going up, and now a bunch of places that should clamp down aren't clamping down, and other places are opening up, and you know, there's a pretty good chance it's going to do that. And if it does that, we're looking at easily hundreds of thousands of deaths before you can get it back under control again. So I don't get it. Yeah. So that's what seems to be happening right now.
So the
modelers, the epidemiologists look at it and say, we're in deep huckabucky. And yet.
So the people who go out and mix it up now, and whether they're protesting or whether they're closely with others, you know, in whatever circumstance now, or think that everything should be, you know, the restaurants Monday in Georgia are going to reopen for seated dining, as I understand it, you know. So those people are going to a greater or lesser extent, let's be conservative, to some extent, those people are going to be playing Russian roulette with exposure to the virus, and they don't, are those people who don't think that they're really susceptible and that it's really not that serious if they're exposed to it or contract it, or they just think that the whole thing is imaginary and exaggerated, and whatever has to happen to restart the economy ought to happen right now, or my small business is going to go under and I don't give a damn about who gets sick, even if it's me.
Right.
You know, what kind of thinking is really going on?
I've heard people say that, oh, it's fine if I get it, it's just going to be like a bad cold for a week. There are people that still believe that. And maybe if you're extremely lucky, it will be. But I've also, some people it will be. But you know, you can't.
But that's certainly quite a spin of the roulette wheel, though. Isn't
I think it is. Yeah. So I think it's hard. Again, just in general, it's most people have a hard time, you know, imagining bad things happening to them. And so I think this is kind of another case of, well, it can't happen to me. And there are a lot of people that do believe that, especially people that are very susceptible, people that are older or immunocompromised. They're taking this very seriously. And I think people that are generally healthy are not taking it as seriously, and they're assuming that they're going to be all right, which is maybe not the case. Maybe it is.
I hate to say it, but it may be. The question is, how many people are going to have to die, and how many people close to people are going to have to die before it starts to sink in? I mean, is seeing mom die of this going to be enough to bring it home? Or are you also going to have to lose your brother like Elizabeth Warren just did to this? Or do you need to lose your kid, or do you need to lose your, you know, how many people close to you do you need to lose before you start to realize that this is a thing?
It's not a joke.
It's not a joke.
Catch-22 of, if we're starting to be successful in controlling it, then suddenly it doesn't seem so bad anymore, and we can open up. And you can't, but that I think is also what people tend to think.
Yeah. Well, and then you get the people, I mean, we talked a little bit about the protesters last time. The irony there, of course, is that it's now clear that the people who are egging those protesters on are a bunch of rich folk that are just social distancing the hell out of this thing, because they're not going to put their own keisters on the line in this, but they're perfectly happy to send the cannon fodder out to say, you guys go out and protest this because our profits are down, and we need people to go fall on their swords for the good of my bank account or my stock portfolio. You look at history and one wonders where the tipping point is, where suddenly, instead of singing the king's praises, all the people who like to walk around with rifles decide to go storm the Bastille. When does that transition take place? When do the feds again become the bad guys in the eyes of those folk? I don't know.
It's quite an exercise, isn't it, in Darwinism and in psychology?
Mm-hmm. Yeah, every day's Darwin Day.
Yep.
But so yeah, we know what's going to happen. Again, we've talked we've talked a little bit about it on the show. Dave, you and I have talked about this many times over the years, is just sort of the progression of magical thinking. A lot of this goes back to the idea that, oh, science, again, they're just a bunch of priests and, scientists, shamans, it's all the same.
It's another thing that you have to have faith in.
It's another thing that you have to have faith in.
So
and
why
it's like, it's
better than having faith in something else.
Except that's crazy. That is absolutely nutsy Fagin. It's not a matter of having faith in it.
Right.
The whole notion of science is that I've got an idea, and instead of trying to show that this idea is right, if I'm honest about it, I'm going to try to show that this idea is wrong. And if I don't try to show that my lovely idea is wrong, there are plenty of other people out there who are going to do it for me.
So why is it, for the both of you weigh in on this, why is it that so many people still today, now, when we know about how galaxy clusters 10 billion light years away from us work in groups, that so many people are thinking about things like this in the same level of complexity as people did 600 years ago?
Allison? I'll take a run at it, but Allison.
In fact, it sounds like it might be a good book for someone to work on.
Sounds like it might be a good book for someone to work on. Yeah, who might be interested in doing that? I don't know.
The problem is kind of the same problem you run into with when you mention math to someone and they're like, oh, that's so hard, I'll never understand it. And they don't even try. They're just convinced that they'll never understand it. And I think things like science are kind of the same way. I mean, science is, when you think of science, a lot of people think of math. And they think that it's something they could never comprehend, and so they don't try.
Yeah.
And I also think in a way that a lot of people think that science is about knowing everything. It's about being able to rattle off how many stars there are in the galaxy, or how many galaxies there are in the universe, or how many species of animal there are on the planet. And while yes, that's useful, and you need to know that for your field, great. Science is more about knowing how to figure out the answer to something if you don't know it. I guess something that I was kind of always told was that you go to college not to learn everything, you go to college to learn how to figure out the things you don't know yet. Or how to even, at the very basics, how to look up something you don't know. A lot of people don't even know that. And I mean, we get a lot of questions, and it's like, if you just Googled this, you'd have a pretty good start. Now I understand, just Googling something doesn't always get you the right answer, and that should definitely not, not be taken at face value, but it's not the knowledge of how to Google something, it's the knowledge of how to Google something, for example, in, okay, now which resource is correct, which source can I trust? I think hard.
I think it goes deeper than that. I mean, first of all, to second your idea about college, the point of a PhD is not to make you think that you know everything. The point of a PhD is to teach you what knowledge is. That here is this one little place where you've gone all the way down to bedrock in your knowledge of it. And then if you're honest about it, you poke your head back up and you look around and you realize that there's this whole terrain of stuff out there that you could pick anywhere and go just as deep. And so having a PhD is really about learning the extent of your own ignorance. But there is a lot of really fascinating evolutionary neuroscience, evolutionary psychology that goes into this. That, first of all, a lot of it is, this is what my group believes. And if you look at an evolutionary sense, I mean, our ancestors on the savannah back in the Pleistocene lived in groups of maybe 50 or 100 people, and their survival depended upon their cohesiveness. And they were facing sort of the same sorts of challenges that their great grandparents had been facing. And the fact that their group was still around was a pretty good indication that at least they weren't doing everything wrong. And so for somebody to come along and say, you know, I think you guys are wrong, is probably a pretty good way to get yourself removed from the gene pool. You know, oh, you guys don't know what you're talking about. Next thing you know, you're somebody's, you know, somebody's lunch. And so there is nothing that is more important to us, wired into our brains. There is nothing that is more important to us than the acceptance and of our social group. And that shows up. In fact, there's been work that talks about, I talk about social signaling. You guys know what social signaling is. Tell us about, so listeners might not. Allison, tell us about social signaling.
Trying to make sure I actually know what you're talking about. I mean, social signaling is just picking up on, you know, oh, sorry, now we're at 40 minutes. Saved by the bell. No, it's picking up on those cues from others in your social group. It's that.
Yeah.
I mean, that's a very, very basic way of putting it, I think.
Yeah, that social signaling is, you say, okay, I do things
because someone else does it and I see it, and I get that cue.
And by doing it, I then signal back that I'm one of you.
Right.
And there's some. And it's done in shorthand, essentially, in groups.
It's done
together. Yeah. It's
done in shorthand, and there's been work that reasonably has found that the more extreme the activity, the more extreme the behavior, the stronger the social signal it is. And that shows up, one of the places that shows up is in outrageous beliefs. That I demonstrate that I am really a member of the flat earther group by becoming more and more extreme in my belief in the flat earth. You know, I become a member of whatever group by becoming more and more extreme in those, and that some of the most powerful social signals that there are people who honestly believe things that are just completely demonstrably false, because that's what their group believes. And so the thing is that you look at one of these people who's part of one of these groups out there, and you say, how in the world can you possibly believe what you're saying? How in the world can you possibly, how? And the answer is that this is their group. That if they were to question that, if they were to go against it, they would lose their group, and their brains are wired to care far more about the acceptance of their group than about anything silly like whether they're going to survive.
They would be cast asunder from the group. So what is it that makes scientists care so much about what the truth really is, and not so much about whether Allison and Jeff like me or think I'm crazy?
I don't know. I guess personally, I think that scientists are kind of a special breed almost. A lot of us, and again, this is not a sweeping statement, but I think a lot of us were kind of outcasts. I mean, at least, you know, I kind of was. I was the kid who was always reading books on the bus instead of talking to other people, and, you know, doing a lot of other things. And so I don't know that all scientists were like that, but I think that a lot of scientists were. And I think a lot of people that kind of come up with these ideas, you don't actually care as much about whether people like you. You care more about finding the truth. And maybe it's a personality trait. I mean, maybe it is something that I know it is something that can be cultivated. Obviously, it's not, you know, you either are this way or not this way. That is not true. But I think that's kind of what leads people towards the sciences, is less caring about what other people think and more caring about the truth. And maybe that's just the start of it.
There are some evolutionary forces at play there. Imagine that you had a group of people that everybody was exactly the same, okay? and a novel threat of some sort came along, what's going to happen to that group of people?
Everybody dies.
Everybody dies. Okay. And so it is not not an evolutionarily stable situation
Right.
to have everybody exactly the same.
Mm-hmm.
And so the evolutionarily stable situation is where most people are, I'm all about what the rest of my group says, and I am horrified by the thought of being an outcast, and so on and so forth. But there have to be a few people within the group who are willing to question that authority, and who are willing to take risks, and who are willing to take new things.
Mm-hmm.
And we know that there are genetic markers for risk taking. For example, there is a gene that if you have this gene, that means that you're much more likely to be the kind of person who jumps out of airplanes and does extreme skiing and that kind of stuff.
I do
And
not
so
have that gene.
I
Promise you right now.
I probably do. But and so it makes sense. You have to have some fraction of the population that is out on the wings, that's actually willing to challenge that. And I have often imagined whether or not scientists whether there might be real genetic predisposition in a lot of people who are scientists, that we just find it easier to challenge the we don't feel like, oh, I have to do what all the popular kids are doing.
Mm.
I really would rather just sit here and read this book, and they can go do what they want to, and I don't care about being ostracized, and it's no big deal. That's a fairly basic characteristic. And I think probably an awful lot of scientists have those kinds of stories to tell. And I don't think it's happenstance.
That's kind of my thought.
Interesting.
But
Yeah.
I don't have the data, so that's why I don't want.
Well,
As a
yeah,
scientist, I don't have the data, but yeah, it is definitely a thought I've had.
That'll be a fun thing at some point to go and dig into and
Right.
see
All right,
what
well,
we
we are
can
at
find
45
out about
minutes.
that. We're at
or
45
so.
minutes?
I think
Okay.
so, yeah, just now.
We can continue the visiting of that next time, perhaps, eh?
Absolutely. That sounds good. All right. So we will see you guys soon.
Thanks.
And goodbye to all the folk out there.
Thank you. Thanks, Allison. Thanks, Jeff. Thanks so much for joining us, everyone. We'll talk to you soon again.